So in this video we are going to study about integrity constraints. So we already studied some of the integrity constraints like primary key, storage key, like that. So first of all we have to define what is the meaning of integrity constraints. Integrity constraints are a set of rules and which is mainly used in order to maintain the quality of information. That is, we know that we are storing different information inside the database permanently. So, in order to maintain the quality of the information which are stored, we have to use certain rules. So, that are called the integrity constraint. And the main purpose of using the integrity constraint is that it will ensure that whenever a user is performing any insertion, deletion or updation operation, the data integrity will not be affected. Okay, so that is the main purpose of integrity constraint. That means we can say that if you are applying an integrity constraint to a database, it will guard against the accidental damage to the database. Suppose that accidentally if any data is lost, if you are not using any integrity constraints, but if you apply any integrity constraints, this can be avoided. That is, if any authorized person make any changes accidentally, that may cause loss of data. So if you are using the integrity constraint, this can be avoided. And there are different examples are there for integrity constraints. Each of them can be performed by using appropriate integrity constraints. For example, suppose that what is one condition? Check the account must have balance greater than 1000. Okay, so we all know that if you are using normal banking system, there in certain banks there is a minimum amount is needed. That is, if you have an account, minimum this much amount is needed. So it can be imagined as an integrity constraint. That is, whenever if you are taking any account holder, there should be minimum balance inside that account. Otherwise we can make a fine, or we can apply a fine. So in that case, so this is one type of constraint. So here checking account must have balance greater than 1000. So it is a condition, it is a rule. That is, if you have an account, it must contain minimum 1000 rupees in its balance. That is, balance amount should be 1000 rupees. And this is the second example. The second example is that an instructor name cannot be null. So we already studied which integrity constraint is used for this purpose. That is, no two instructor should have same roll number or same name. The instructor name cannot be null. So here we studied not null constraint. So certain attribute value we cannot give null to that value. So for that purpose we have to use not null. But here it is one example in which the second it is an example of second integrity constraint. The third example of integrity constraint is no two instructor have same instructor ID. So which one is used here? Here we are using the concept of primary key. So if you are applying a primary key, we know that to a particular attribute, we know that no two tuples should contain same value to that particular attribute. So that is another example of integrity constraint. And this is the last example of integrity constraint that we are going to discuss here. That is, every department name in the course relation must have a matching department name in the department relation. So this is the this means that suppose we consider another example. Suppose we are, if a student is coming to our college, and suppose he or she is trying to make an admission in any department, that department should be there inside that college. For example, if a person is coming, if a student is coming to join for MBBS in our college, that is not possible because it is not a course which is taught or which is there in our college. So that is another type of integrity constraints. We can call it as a foreign key. That is, if suppose the department is one table in which department name is the primary key. Suppose the same department name is used in another table, okay, then we can make an entry to that second table if there existed department in the department table. Okay, that is the meaning. The same concept is used in this example. So these all are some of the examples of integrity constraints. So integrity constraints means they are set of rules that help to avoid the accidental damage of data, which can be done by any authorized users, and it will maintain the quality, and it will guard against the accidental damage to the database, and you have to write certain examples of integrity constraints. So normally we will add the integrity constraints along with the create table command. That is, integrity constraints are usually given to, it's a part of the database design. That is, whenever we are designing a database, for example, whenever we are creating a table, we know that a table is a part of a database. So whenever we are going to create a table, then at that time we will try to apply the integrity constraints. So when we see normal integrity constraints like primary key, like that will be applied while we create a table. But it is also possible, suppose that you have created a table and you forgot to specify the primary key. It is possible after that, after creating a table, it is also possible to apply certain integrity constraints after creating the table. But for that purpose, we will have to use the alter command. And there is a syntax for alter command is alter table. After that, you will specify the table name, alter table name, and after that you have to specify the appropriate constraint. So here I will show you how to apply integrity constraint. Suppose I am creating a table which is called student, okay, and the student contains these three attributes like student ID, student name, and phone number. And in while I am creating the table, I forgot to specify the primary key, and I want to make student ID as the primary key. So what is the command which is used for that? For that purpose, first of all, you have to write alter command. You all know how to apply the alter command. Alter table name. Okay. Then after that, you have to write add. Then we can specify the corresponding constraint. That is, here I am going to add student ID as the primary key. So how you can write the command? Alter table student, add primary key std ID. Okay, and after executing this command, you can see the message that the table altered. That means now std ID is set as the primary key. But one point you have to remember while you are setting, you are trying to apply to alter a table and you are trying to add a constraint. So that is that when you first of all suppose that first you create a table, and after that you are trying to modify the table or alter the table in order to add an integrity constraint. So when we try to execute the command, first the system ensures that the relation satisfy the condition. So in our example, first of all, we try to create the table, and after creating the table, you try to add a primary key. Since there was no value inserted into the table, the alteration was successful. So when you are trying to make a modification, trying to alter the table and trying to add the primary key or any integrity constraint before executing, after executing this command, first the system will check whether it is possible to make changes to the relation, or the relation satisfy this specific constraint. If it already satisfies this constraint, then only this new constraint can be applied to the existing table. Otherwise, the command will be rejected, and that is very important point. Now we have to study some of the integrity constraint which can be applied to a single relation. That is, if you have a single table and there are certain integrity constraints which are most popular one which can be applied to the single relation, that are, the first one is not null, the second one is primary key, the third one is unique constraint, and after that the next is check constraint. So Check constraints format is check in bracket, you have to write the predicate or the condition. So these are the 4 different integrity constraints that can be applied to a single relation. Which are they? The first one is not null, then primary key, then unique, and check constraint. So first of all, we have to study the first integrity constraint, that is called the not null. So in not null constraint, we know that whenever we are discussing about a relation, whenever we are applying values to a relation, null is a member of all domains. For example, if you are taking a phone number, we know that a phone number can be any numeric value. But if it, that is the domain of that phone number can be any value, any numeric value. But null is a element, or it is a member of all the domains. And by default, if we are not giving any particular value to an attribute, it will be taken as null value. But in some cases, for certain attributes, it is not possible, or it will be inappropriate if you apply a null value to any attribute. For example, if you are entering the details of a student, you have a student relation is there, in which 4 attributes are there: student ID, student name, then maybe student address. So in that case, it will be inappropriate if you are not giving any particular name to a student. That means that if you are storing the details of a student without the student name is not a good, not a good information, or it will not be any useful information. That is, you are storing all other details about the student, like ID, then courses, like that, without giving the name of the student is not a useful information. So in order to forbid that, that is, if you want to restrict that, that is, we cannot give a null value to certain attributes. For that purpose, we can use the constraint that is called the not null. So as I said, if we have a student table, we cannot store the information of a student without the name of the student. It will not be any, it will not store any useful information. Because student name is very important, then only we can store all other information to a table. So that is an example of a condition where we can apply the integrity constraint, which is called not null. If you have a student table, if you want to apply a not null constraint to name, we can see how it can be applied. So while you are creating the table, we know that we will create a table by using the create table command, create table student, and then we will write the attributes, and which all attribute we want to specify as not null, that should be specified like this. For example, name, that its type, not null. That is the way how to apply the not null constraint. Then, for example, other example is budget, numeric, not null. So these constraints we are added while you are using the create table command. So if you have a create table command, if you want to make certain attributes whose value should be not null, after specifying the type, you have to write not null constraint. So not null, if you are applying not null constraint to any attribute, it is not allowed to insert null value to those attributes. That is, if you are making the student name as not null, and if you are trying to insert a value or a tuple to a relation in which the name field, if you are setting, if you are not applying any name, it will show error message. So that is one constraint. So we studied the first constraint, not null constraint. Second one is unique constraint. Unique constraint means that suppose you have it is also inserted in the same manner as not null. While you are creating a table, if any particular attribute you need to set as unique, you have to use the unique keyword. So unique in bracket, you will suppose that you have n attributes are there, which are called a1, a2, etc. am. The unique constraint means that the attributes, all these attributes a1 to am will make a candidate key. So we already studied what is the meaning of a candidate key. If you are taking any two tuples, any two rows in a relation, no two rows will have the same value for this a1 to am. So that is the meaning of a unique constraint. The next one is check constraint. Check constraint means that suppose that a particular attribute can only take value from a set. Okay. For that purpose, we are using the check constraint. And check constraints format is check in bracket. You can specify the predicate. For example, here I will show you one example. We know that we already studied a table or a relation which is called section, in which we have a attribute which is called semester, and we see different values for a semesters are fall, winter, spring and summer. If you check that table, it will be more clear. So that means the semester can only take values from this list. So how we can apply this constraint? For that purpose, we have to use the check constraint. So whenever we are trying to create the table, create table section, the first attribute, second attribute, like that. While you are then you are setting the primary key. You are setting the primary key, and after setting the primary key, we can write in bracket. So we already set the semester. It is also specified here. Semester is already specified here. And after setting the primary key, you know that the semester can only take values from this list. So you will write it as a check constraint. Then you will have to write a check constraint after specifying all these things, including the semester data type, semester attribute, check that particular attribute in this one. Okay. That means that always whenever you are trying to insert a value to this table, first of all, if you are using any check constraint, this condition will be checked. If the semester is not from this list, the insertion will not be completed. So that is the meaning of a check constraint. And the last one, primary key, we already studied the primary key, so I am not specifying that one in detail. You know the meaning of a primary key and all other details that you can write in your own words. Then referential integrity. Referential integrity means our foreign key concept. So we already studied the concept of foreign key also. So that means that suppose that if you have two tables are there, and suppose there is a Maya. എന്താണ് തെക്കോടെ കിടക്കണേ? അതിൽ ചാർജ് ഇല്ല, ചാർജ് കയറുന്നേ ഉള്ളൂ. ഇപ്പോൾ ചാർജ് ചെയ്യാൻ വച്ചതേ ഉള്ളൂ. ഇപ്പോൾ കാണാൻ പറ്റില്ല, പഠിക്കണം രാവിലെ.